Now we come to our today's speakers with the title OPC UA for Weihenstephan Standards. I would like to welcome Ms. Romy Ries, Mr. Christoph Noput. Both are Chair of Brewing and Beverage Technologies from the Technical University of Munich, and Mr. Michael Pritschula. He's a consultant of the Food Processing and Packaging Machinery Association at VDMA. And now I'd like to hand over to you, Michael.
Okay, thank you, Mark. I have the very easy part. First of all, welcome to everybody. We should be like 26 participants in the meeting. A few are still missing. But I would like to introduce to you quickly the agenda for today. We will have an introduction into the domains of Weihenstephan Standards, use cases and reason for standardization. One of the next slides will also explain that. Insight into information modeling, and that is the heavy part. I hope you have enough coffee in front of you. And the current project status. Christoph, next slide, please. So, why is that so important that we have Weihenstephan Standards? I think it was 20 years ago, a little bit before my time in VDMA, that people realized we have similar machines, we have similar processes, so the machines actually should have a standardized definition of interfaces and communication. And we then try to mirror that into our branches, which are actually bakery, as you see here, meat processing, beverage production, dairy technology, confectionery, a little bit of vegetable raw material processing, a heavy part in packaging, and also production of pharmaceutical and cosmetic products. But that right now, the last part is not reflected in Weihenstephan Standards, I must say yet, but we will see what the future brings. Very quickly, we are the largest of the 38 industry-specific associations within VDMA, and we have more than 320 member companies who manufacture the machines for all these branches. Yeah, that was my quick part for you, and I'm very happy that we now can have the presentation from Christoph and from Romy. And I wish you fruitful information, and as I said, refill your coffee. Okay, thank you.
Thank you, or refill your beer, because that was where we're starting 20 years ago with the domain of the bottling and packaging lines for breweries. And that's what the starting point for the Weihenstephan Standards to standardize the data informations from those bottling plants. Those bottling plants are highly automated right now, and they're filling around about 60,000 bottles per hour. So with the first slides, I just give you an impression of our domains, which we are covering within the food processing industry, so that you figure out what's the challenges we are facing at the end by standardizing all those machines. The next domain, we have the WS food standard is in the meat and sausages production. So you see also in the pictures that there are some process steps working out by workers. So the challenge here is to also validate information about the batch and article tracing, for example, to guarantee the customer that the products are very safety. And the next domain we are covered with the WS Bake standard is the bakery. So of course we are baking breads, and in German we are also baking pretzels, but we are doing also concerning about the cookie production in this domain. With the WS Brew, we standardized the information about the brewing process part itself. So it's concerning the brew house, the fermentation and the storage tanks. And last but not least, our last domain we standardized is the sweets and confectionery domain. With on the left-hand side, you see a picture of a molding plant. So that's a machinery for producing chocolate. And on the left-hand side, a machinery for producing jellies. So what I'd like to do with these slides to you is show you how many facets those domain have. And this is also our challenge we are facing. Because we have 5 domains already covered in those food processing and packaging industries so far. And we are dealing right now with around about 160 different machine types. So we have machine types from the filling machine and the pack, and also molding machine in the sweets or kneaders in the bakery industry. And all those machines, additional special machine construction. So it's hardly to find 2 machines with the same configuration. And this we have to reflect also in our information modeling, because we have to be very flexible to adapt to these different machine types and to adapt to the special needs in the production lines. We started around about 20 years ago, was already mentioned. So we started with a flat list of different data points. So far, the data point in this view, or the point of view, is the temperature of a product, the pressure of a product, or the status of a machine. And at all, we have counted 550, so roundabout. But what we are doing right now is not exposing flat lists in our machines, but instead we are modeling this in an information object-oriented way. And we'll see in the next slides what we're doing in the Weihenstephan Standards now. Harmonization is a big topic in our domains, because what we are doing is a harmonization within a food processing domain. So we are making a harmonization within the pack, for example, with the machine builders, with the end users, and also with the system integrators and the suppliers. But the harmonization is also between our domains. So if you imagine you're producing a chocolate cake, you are facing aspects of the bakery domain for baking your cake, and then facing aspects of the sweets domain when you're enrobing your cake with chocolate. And at the end, you're facing aspects from the pack domain by packing your cake for the consumers. And last but not least, we are also doing a harmonization with other domains outside our food processing and packaging domain, because it's also the spirit of OPC UA to have a common understanding of what we are doing there. But to this point, later on, a few more words. Who we are, Romy and I, working at the Smart Production System Research Group at the TUM. So we are inside this blue bubble there. And with our formerly chair, we are starting the Weihenstephan Standards and founded the Industrial User Group. And inside this Industrial User Group, the companies from machine builders to end users are sitting in a round table and defining the Weihenstephan Standards. When we started to publish our Weihenstephan Standard also via companion specification over OPC UA, we founded a joint working group, Weihenstephan Standards, with the cooperation with the OPC Foundation and also with the cooperation of the VDMA. The Weihenstephan Industrial User Group is still growing. So we are over 100 partners who are taking part in the Weihenstephan Standards and working with us on the standardization. As I mentioned before, this is the machine builder side, this is the end user side, as well as machine or IT integrators and OEMs. So we have a good overview of all the requirements, of all the needs of all partners there. And I think that's the key why the Weihenstephan Standards are so successful in the industry. But to explain why we need a standardization, I will turn it around. What happens if we haven't a standardized data interface in our production line? So what you see are 3 machines from 3 different manufacturers. In this case, it's a speed production, so we are producing chocolate bars here, and all those machines exposing information about the health of the machine, exposing information about the process they are currently running, and we have consumers of this information, which are executing a bunch of IT functionalities, and most of the time this isn't one technology or was one software running all these IT functionalities. There are also different companies taking part for this task. So what you have to do is when you're integrating a new machine inside your system is you have to talk with everybody which information is needed, which information do you need in which data types and so on. So this is very time consuming, and there the Weihenstephan Standards come into place because we are covering three aspects with the Weihenstephan Standards. The first one is we are defining IT or MES functionalities, and depending on the point of view, if you're the classical pyramid or the new industrial 4.0, and within those, with the IT functionalities as a starting point, we are defining which machine in the production line have to provide which information to execute those IT functionalities. So the second and the main part of the Weihenstephan Standards is the information model. Formerly the list of data points, now it's an information model, which we are designing for those IT functionalities. And the third aspect we are concerning is the communication interface. So how to transport the data from the machine up to the higher IT system. And last but not least, we are providing domain-specific evaluation recommendations for our 5 domains so far. In the next slides, just a few impressions about those 3 parts. So the first one is the IT functionalities. So we are covering the possibility or the data which is needed for dashboards, for a single machine, or for overview of your whole production line. And we are also providing those information, for example, to calculating KPIs for your production lines. The information models or data points, this is the transformation we are facing right now, we are running right now, is from a single list of data points to a structured information model. Rumi will tell you more about this topic in the next slides. And last but not least is the communication interfaces. So in the past, so 20 years ago, we doesn't found any suitable protocol for our needs to transport this data from the machines to the upper IT system. So we developed a proprietary TCP/IP protocol, the WS protocol, in the first place, but this isn't the way to do data exchange in Industry 4.0 world. So we are switching or already switched to OPC UA, and the WS protocol is reaching the end of life in the next years. So I'd like to hand over to Rumi, and she will explain you about the transformation of the Weihenstephan Standards.
So I would like to show you how the Weihenstephan Standards have developed and at which point we are right now, because we have several different versions for the single domains. So as the VDMA, we also started the development more than 20 years ago now. In the past, the communication was only possible via WS protocol, which was a proprietary TCP/IP based protocol. The first domain which were developed was for the bottling and packaging domain, and then in the following years, other domains are followed, as Christopher already showed you. Since 2021, it is also possible to transmit the data via OPC UA, but also, as Christoph already mentioned, in the past we had this like flat list of data points defined for WS protocol. And what we've done in version 10, we just transmitted or provided the information via OPC UA, but data point and the modeling of the data point itself remained more or less like a flat list. In last year, we released our latest information model, our latest domain, WS Suites, for the confectionery production plants. And here in this version 11 of the Weihenstephan Standards, we totally changed the way of modeling the informations. And as you see also, it is only possible to transmit or to provide these informations via OPC UA, so it's not possible to access them via WS protocol. So to give you a little bit more ideas, what is behind both version 10 and version 11 version of the WS, which are possible to access via OPC UA. I'd like to show you how a server instance for our machines would look like. Of course, we're not defining our server instance from scratch, so we're using the existing meta models of the OPC Foundation. We are using other companion specifications where we find type definitions which are useful for us. I think Christopher will spend more time later to get into detail here. And of course, we have our own Weihenstephan Standards companion specification, which we are using. Point or a little bit the difference between our companion specification and other companion specifications is that in our companion spec, we have defined like a general machine type, an empty machine type. So it is clearly defined how a server is structured, which data types to be expected, but it's not defined here that, for example, a filling machine has to provide a special bottling temperature or something like this. So this information is missing here, and this gap is then covered by our own kind of documentation. In this case, we've called it for version 10 the WS modeler or templates in a WS modeler. So what is it? It's just an Excel-based permutation table. So in the top row, you find all the machine profiles, machine classes. And on the left, you have these like over 440 different data points, and you clearly can see which machine has to provide which information mandatorily or can provide them optionally. These data points, you've saw this already, is of course defined in a OPC UA manner, like browser name, display name, and so on. But we have some limitations here. And this our tool is also capable to create a node-set file. So it's not only for documentation purpose. You can configure, you can create a machine, select a machine, create them, configure the machine, select optional data points, for example, and then you can create a node-set file with this WS modeler. And at the end, for example, here a tunnel oven would look like this, or OPC UA server of a tunnel oven. You have the machine, and underneath the machine, you find these functional group folders. And within these folders, for example, counters, identification, measured values, whatever, you see all the data points which are interesting or which are, you're interested in of your machine. As you see, for example, here, humidity or temperatures, states, machine speeds, etc. And as you see, and I've already mentioned, it is more like a flat list of data points, which are structured by these functional group folders. This leads us a little bit directly to the limitations we still have in version 10. So as I said, the current companion specification 4600 only describes a meta model for a WS machine. So you can instantiate, of course, a WS machine type, but then you get an empty machine. There's no content, no data points included here. So in this case, it is not the proper type system in sense of object-oriented modeling. You have to do this with our modeler or manually. It is not component-based. So if you think of this tunnel open and you want to get all informations, for example, for one certain temperature zone 1, then you would have to look up in all these different folders to get all this information. So there's nothing like a component in version 10. Then we have defined also specific WS subtypes. So for example, a WS-based object type only to keep the backward compatibility. So we included a tag number here, which was something, we needed in WS protocol, and we kept them to have like a transition, with the backward compatibility. And then our browse names are really cryptic, so we kept them from version 9 WS protocol, and in some cases they're kind of understandable, like Mach SPD, but sometimes they are really cryptic, and even I would have to look up what means prot-ul, what's behind these information. In version 11, so with WS suites, we've went a completely different modeling approach. We didn't do this just for fun, but we were forced to do this in this way because we were no capable to do it in the same way like before. Just to show you, we didn't do this by our own. We had really strong project partners on board here who brought in their experiences and their knowledge, and also their requirements on the standards. So here, machine builders, of course, IT integrators, and also the producing companies, big producing companies, which are really forced this standard. Like I said before, actually, we plan to do it in the same way in this project, like describing a certain machine and identifying all the relevant informations and just assigning them to one cooling station for this example here. But we saw that for these short cooling stations, this might, it's possible. But if we consider, or if you think of a longer cooling tunnel, if you are having more temperature zones and you're still interested in all these informations from the single zones, it's quite difficult to really predefine all these data points, name them, and predefine all possible configurations. And this is even a simple example. If you think about a molding plant where you have more components and have several times a depositor or no times, it's even more complicated. So that's why we changed our way of modeling and went to a component-based modeling approach, where, for example, here a cooling station consists of multiple components, for example, a cooling zone. And in this case, we have cooling zone type, and underneath the cooling zone type, you always find, of course, or in this cooling zone type, you find a set temperature and temperature. And if you now have like a cooling tunnel with 5 temperature zones, you can just instantiate this cooling zone type 5 times, and you always get the same information, the same naming of the variable, and you can easily access them. I now want to skip the following slides and would like to show you what we defined in detail in Sioma. And this is just for then the recording. So what do we define? I just highlighted our older companion specification to also show you what I've said before. We have here in the current version of the companion specification, which is released, empty machine type. So you find all these functional group folders underneath, but if you now go into these folders, there are no data points assigned here. But still, in our current version 11 of WS suites, we use these WS machine type to as a super type for our WS suites machines. So within WS suites, we defined like I think it's 14 different WS suites machines for production of bars, of chocolate, of chocolate tablets and of jelly. And if we are now looking for one, for example, here, molding plant type for producing chocolate bars, we see now underneath it is, of course, not empty. So we have a lot, we still have these folders, as we have on the super type, but underneath the folders, we find, of course, relevant informations which are apply on this high machine level for a molding plant. What we also see here, and you see it, that you find all these components here underneath. You can see it here a little bit better. So we have a lot of components underneath the molding plant, which can be, which has to be there. For example, here is the demolding station. So whenever you produce a chocolate, you need a demolding station to get the chocolate out of the mold. So this is something what is also defined here. It is mandatory. Other components, for example, here, cold stamping station is optionally. So it's sometimes for some people it's a little bit confusing, but a non-ticked box for mandatory means just optional. So in this case here, a cold stamping station, you don't have to be, you don't have to have necessarily in your line. So it is optional. And you have a lot of placeholder. So here is, for example, a component defined, a depositor, which fills the chocolate in the mold. And of course, you need them at least one time. So it is a mandatory placeholder. And others, for example, here, such a roller type, licking roller, it is an optional placeholder. You can have them multiple times, or you can't have them not have them at all. So in this way, we defined our WS Suites machines. And I now want also to jump to some components. So all these components, this is already structured in the future way. So actually all components and machines are in the current version in one namespace. In the future, we want to split them, but Christoph will tell you more about this. So what we have also defined from WS Suites is all components. So during our definition, we saw that we have a lot of five informations which are applicable for all components. So we decided to define a generic component type with these 5 informations here, and they are all optional. So you don't have to assign, for example, an item state to an agitator, but if you have to, you already have the right place and just have to tick the box. And from these component type, we defined over 60 different components or specific components. And I like to show you also here on this component level, you have also underneath other components, for example, here stamping head from stamping head type, and it is inside the cold stamping station. And we have on the component level also, of course, these variables. Wherever it was possible, we also tried not to define the things from scratch, just to save time and make it more easy. We, for example, here defined a motor type, which is a subtype of the component type, of course. And then we derived here an FC motor type with even more information on this level. And then, for example, here servo FC motor type. So in this way, we try to reuse our type definitions and just doing new ones by subtyping. Christoph already mentioned that harmonization is also a really important point for us. So not to define a hopper, for example, here for the molding plant and for chocolate mass and the hopper for jelly mass. So instead, of course, we try to define here a hopper which fits both requirements or the requirement for the whole suites domain. And you also can see it here, not directly, but if you have here with mouse over, you see it's even smaller. that this hopper here is, for example, within a starch sprayer. Here we have a hopper within a sprinkler. Here, I think here's also a slab former, so this is for bar production, or here for chocolate. So this is, defined in such a generic way that it fits these requirements of all these production lines. And then, of course, this is now the really important part, I think, also or the difference with these empty machine type and proper machine type or proper molding plant type, that if you now instantiate a machine, I've already done this here in our machines folder, I instantiated a molding plant, that you get all the informations already within your instance. So you have the counter, all the folders, all the variables, and then you start with at least the mandatory placeholder. For in this case here in Sioma, it starts with a 0 because we haven't gave these placeholder a fixed name part. So this is why if you instantiate, you get a null at the beginning. So this null, you see, it's a depositor type. It was a mandatory placeholder. You always have to have one. And that's why it's included here. And you see also here, there's a demolding station. You always have to have one demolding station. So it is here. And if you now want to further configure your machine instance, you can easily do this here by, for example, here adding a scraping station, and all information comes with this scraping station type. You don't have to add manually, or you can add manually data points if you have further requirements, of course. But here within this scraping station type, you also get a lot of information already. And for other optional placeholders, you find here, for example, a near field heating station for heating up the molds. So if you do this in this way, you can just instantiate one of these near field heating stations. Also here, as this is a completely freely nameable placeholder, you start with just a number, not with a name, and you can give them whatever you like. Near field heating station 1, 2, left, right. It's up to you, but with this type, you get all the required information about this component then. Okay, so jump back. I think this was a little insight in our information model. And I just want to end my part with the slide how a tunnel oven also would looks like now in version 11, or then later in the proper companion spec. That of course you still have these function group folders also in version 11, but then you would not find all the information spread around the folders. So you would have like these baking zones, for example, or cooling zone for cooling tunnel, and underneath these zones you always have the same information and the same named variables. But last year, I said it already, last year we released WS Suites, but our development is going even further. So beginning of this year, we started to transform also the WS Bake domain to these component-based way of modeling. And these also we are doing together with other project partners, with machine builders, IT integrators, and producing companies. And also a really good information or good decision we already made last year was that together with our WS industry user group, we decided to publish these companion or the WS as real OPC UA companion specifications. So not to keep the information between this kind of layer, what is not a companion spec, but to really transform them in a new companion spec series. So in this development to transform WS Bake, but also Suites, has started also this year. And Christoph will now show you what we have planned for this new companion spec series.
So now we have a lot to do to start a new companion specification series. Why do we have a new series and not only an update for the existing one? Because we have breaking changes to the backwards compatibility with the WS protocol. So we have the chance to start from scratch in a way to bring all these lessons we learned in the Suites project to all of our domains, to developing or modeling OPC UA companion specifications with object-oriented machines. So what we are doing is we developed a layered model, but this is still work in progress. So what we are doing now is the work of the joint working group and the current status there. So in this layered model of the new companion specification series, at the end, of course, you have your instances of your machines from the different domains. So we are still having this domainic centric view in our companion specs. And at the very bottom, we are starting, of course, with the OPC UA meta models and built-in informations from the OPC Foundation, from the core specs. What we are doing right now is, or what we're doing in the same way, is we are searching for companion specs with already existing type definitions for our own models. So we identified a few of them. And on top of this, we are starting with our first companion specification. So this is the WS basis companion spec. And we are still searching. So the list is not completed so far. We are looking for more in already existing companion specifications, which we are using in our basis companion specification. On top of them, we have our domain specific companion specs. So we are starting with the Suites and the Bake companion spec because both of them are developed in a component oriented way. And as before, you are able to extend those models Romy showed you before with your own vendor specifics information. So if you're having a machine with some specialties which we haven't thought of so far, or it's a unique way you can provide some information, more information, then you can add them to our existing information models onto our types and instantiate your machines at the end in your line. So this is the way we are starting right now. This is what we are currently working on. But of course, that's the big picture is at the end that we have all of our 5 domains in this new companion specification series available for you in the future. The current task we are running is to defining a generic WS machine type with our joint working group so far. And so we are looking for other companion specs, as mentioned before. And I like to take the opportunity here to say thank you to Heiko and Wolfgang Mahnke for the really great work they are doing in the joint working group for machinery. So what they are doing is the harmonization between other domains. So the joint working group for machinery is looking inside other existing companion specs, especially for especially for companion specs which are maintained by the VDMA, and identifying similarities in all those companion specs and bring them to a standardized, harmonized way in the companion spec for machinery. So for example, they identified that almost all of those companion spec need a way to make an identification of the machinery possible over OPC UA. And so they developed a type for the machine identification as well as for the component identification. And so they are going through all those specs and identifying more or identified more similarities. So they defined a way to transfer process values, for example, with additional information, additional to the engineering unit, but also to limits with the process values, to find a way to standardize the machine states and build add-ins for job management. So a way to bring a job down to a machine and get the results from the machine up to the higher IT system when the job is already executed. And now still in work in the Joint Working Group for Machinery is a basic server structure, which we are waiting for because we want to rethink about the way we are organizing our information in the past. So you saw the folders Roby showed you before. So we have to decide if this is the proper way for the Weihenstephan Standards to do this in the future, or to switching, for example, to this basic server structure from the Joint Working Group for Machinery. And we are also waiting for the energy management, because this is in this times more needed than ever to figure out which energy your machine is consuming for producing the goods. So this was a starting point. Now we are filling this WS Basic companion spec. So if you have a view to an OPC UA type system, at the end we have the instances for our machines. In this example, the molding machine 2 and the kneader 5. And those machines are instances of the type definition for a WS molding type or WS kneader type. And those are one of the 160 machine types we have to define in our Weihenstephan Standards. And both machines are subtypes of a generic WS machine type. And the machine type itself is a subtype of the WS from the base object type, sorry. And now the IT functionalities I mentioned at the beginning comes into place. So we are looking for different IT functions, for example, the machine identification, and we are using right now more or less out of the box the as-in identification block from the companion spec for machinery. As well, for calculating our KPIs, we need the status of our machines, and we are using out of the box the machinery operating mode. So it's a state machine to describe the states of a machine, more or less out of the box in our generic machine type. If you have a closer look to the operating modes, then we are still working on that. We have substates, so to describe it in a more specific way for our domain, but starting point is the status from the machinery. And this we are doing for all of our other IT functionalities, which we are defined or figured out so far, which are important for our Weihenstephan Standards. And this is the first step. So this is the harmonization with the Weihenstephan Standards over our domain borders with other domains. And now we have a look to the harmonization within our domains or between our domains. As Romy showed you before, in the suites domain, we have a cooling tunnel. This cooling tunnel exists of different cooling zones with different temperatures. And in the bakery domain, we have a similar machine, but we don't cooling there, we are heating there. It's a tunnel oven for baking our goods. And with both of those machines, we are building a generic structure of tempering zones. So it doesn't matter if you're heating or cooling inside a zone. And it's modeling rules, the mandatory modeling rules. So in your machine have to be at least one of those tempering zones. But it depends on the concrete application if you have one of those tempering zones or more. It depends on your application if you are heating or cooling there. And this is what we are doing with our harmonization. And those components are defined in our WS basis companion spec in the first one, as well as other components we are using in our different domains then. What we are doing, also doing is, so we defined a hopper, for example, for our WS suites domain. We are also sure that we are having hoppers in our WS bake domain. But what we're doing right now is to have a look to other companion specification outside the Weihenstephan and looking if there are also predefined hoppers there. If it is so, then we are checking, are those information models, are those types already existing, are suitable for our requirements? If it's so, then we are using this component types in our standard. Otherwise, we have to define them at our own. So the first companion spec in this new series is contains a generic VS base machine, which is the starting point for our other machines. And we have the collection of all of our Weihenstephan Standards components so that we can use them as a toolbox for our machines later on. And this is the way or the status we are working on. So beside the basis companion spec, we are working on the suites and bake companion specs. In this companion specs, we are defining our machine types assembled by the components we defined in the basis. And this is the starting point for you to create your instances for your machines in your production lines. This is those three companion specs. We are heading to bring them as a release candidate by the end of the year for you. And so it's still a lot of work to do there, but we are optimistic that it's doable for us. And we have also the next domain planned. So we did a research proposal to get the money for the new research project, and it's actually planned that we can start in the Q4 this year to do a rework of our WS Brew domain to bring them also in this new companion specification series as a companion spec for this domain. We also keep in contact with other companies from the bake domain, and they are all highly interested to do this with the WS Pack domain to bring them up to the new object-oriented and component-oriented modeling approach. And this we'd like to start in the next year. For the WS Food domain, we haven't any timetable so far, but we are pretty sure that this will also come in the future. So we face huge challenges, in my point of view, with our food and packaging domain, but we accepted the challenge. And we are so far that we are having developed an layered architecture, which is provides a solution for our 5 domains so far. And we are pretty sure that it's also possible to bring all our 160 machine types to this modular structure in this layered architecture approach. We are doing a lot of harmonization work right now. So we are doing the harmonization work with our Weihenstephan Standards industrial user group. So they are very helpful for us to figure out which data points or which informations are needed and which are optional and which are mandatory. And of course, the OPC community with the Joint Working Group for Machinery are also very helpful to achieving our harmonization tasks so far. And we are finally there that we are going to publish our Weihenstephan Standards information models as OPC UA companion specification in a common way your knowing this companion spec. So that's from our side so far, and we are open for your question.